Today's topic is using combinations in probability. Combinations give us an easy way to calculate the number of ways in which an event can occur. We'll look at two problems to see how they work. Problem 1. A fair die is rolled. A. What is the probability of getting a composite number on any roll? And B. What is the probability of getting a composite number exactly once in 4 rolls? To find the solution, let's consider part A. What is the probability of getting a composite number on any roll? Recall that a composite number is a number that has factors other than itself and 1. Thus 4 and 6 are composite numbers. The numbers 2, 3, and 5 are prime numbers. The number 1 is neither prime nor composite. So of the 6 numbers possible on a roll of a die, 2 of them are composite. Thus, the probability of getting a composite number on any roll is 2 out of 6, or 1/3. Now let's consider part B. To find the probability that the number is composite exactly once in the 4 rolls, first subtract the probability that the number is composite from 1, the total probability, to find the probability of the number not being composite. 1 minus 1/3 is 2/3. This is pretty easy to see. Since there are 4 non-composite numbers, 1, 2, 3, and 5, the probability of rolling one of them is 4 out of 6, or 2/3. Now we need to consider exactly how one composite could occur in 4 rolls of the die. Let C represent a composite, and let N represent a non-composite. It is possible to get C on the first roll and N on the next 3 rolls. The probability of this event is the product of the probabilities of each of the individual rolls, or 1/3 times 2/3 times 2/3 times 2/3, which is 1/3 to the first times 2/3 to the third, or 8/81. Or it is possible to get N on the first roll, C on the second roll, and N on the next 2 rolls. Notice that this will have the same probability with the factors in a different order. 2/3 times 1/3 times 2/3 times 2/3. The product is still 8/81. Similarly, the remaining cases NNCN and NNNC will have the same probabilities. Thus, the event of getting 1 C and 3 N's has a probability of 8/81 in each of the 4 ways it can occur. That means that the probability of getting a composite number exactly once in 4 rolls is 8/81 times 4, which is equal to 32/81, or approximately 395 thousandths. Because we had only 4 rolls, it was fairly simple to list each of the ways that one composite could occur. We had CNNN, NCNN, NNCN, or NNNC. However, in a more complicated problem, it would be nice not to have to list each of the individual scenarios in order to count them. Combinations give us a way to count the number of ways an event can occur without listing each of them. In this case, we wanted to have exactly 1 composite out of 4 rolls. That is the combination of 4 things taken one at a time. So, using our formula for combinations, we'll divide 4 factorial by the product of 1 factorial and the factorial of the difference of 4 and 1, or 3 factorial. 4 factorial is 4 times 3 times 2 times 1. We can divide 3 factorial, which is 3 times 2 times 1, out of both the numerator and denominator. 1 factorial is 1, so we end up with 4 divided by 1, which is 4. This is no surprise. We knew that there were 4 ways our event could happen. Once again, we can multiply the probability of the event occurring one particular way by the number of ways the event can occur to get our probability 8/81 times 4, which is equal to 32/81, or approximately 395 thousandths. So why bother to use combinations? Obviously, we didn't need to use combinations to figure out that there were 4 ways for us to get exactly one composite number in 4 rolls of a die. It was easy enough to list them. But if we had wanted to get exactly 3 composites in 8 rolls of the die, you wouldn't want to list the ways that event could occur. There are 56 of them. That's where combinations help us, as they will with the next, more difficult problem. Here's our second problem. 2 fair dice are rolled 6 times, and the sum of the numbers that come up is recorded. Find the probability of these events. A, the sum is 8 on each of the 6 rolls, and B, the sum is 8 exactly 2 times in the 6 rolls. To find the solution, let's consider part A. When the first die is rolled, there are 6 possible numbers that can come up. The same is true for the second die. Thus, by the fundamental counting principle, there are 6 times 6, or 36, possible outcomes for rolling the 2 dice. Of those 36 outcomes, 5 outcomes have the sum of 8, 2 and 6, 3 and 5, 4 and 4, 5 and 3, and 6 and 2. So the probability of getting a sum of 8 on one roll is 5/36. Since the rolls are independent, multiply to find the probability that the sum is 8 for all 6 rolls. 5/36 times 5/36 times 5/36 6 times, or 5/36 to the 6th, which is 15,625, divided by 2,176,782,336, or approximately 718 millionths. Now consider part B. To find the probability that the sum is 8 exactly 2 times in the 6 rolls, first subtract the probability that the sum is 8 from 1, the total probability, to find the probability of the sum not being 8. 1 minus 5/36 is 31/36. Multiply to find the probability that the sum is 8 2 times and not 8 4 times. So that will be 5/36 to the 2nd power times 31/36 to the 4th power. This is the probability that 2 8s occur, followed by 4 rolls that do not yield a sum of 8. But that is only one of the many ways that 2 8s can occur in 6 rolls. The 2 8s may occur on the last 2 rolls, or the 2nd and 4th rolls, etc. So we need to determine the number of ways that the sum can be 8 twice out of the 6 rolls. The position of the 8s is not important. To calculate this number, we can use a combination of 6 rolls taken 2 at a time. That's 6 factorial divided by 2 factorial times 4 factorial, which, after expanding out the factorials and reducing, leaves us with 6 times 5 divided by 2 times 1, or 30 divided by 2, or 15. While we could feasibly have listed all 15 arrangements, using the combination formula simplifies the task and ensures that we don't overlook one of the possibilities. Finally, multiply and simplify. The probability that the sum is 8 exactly 2 times in one particular way in the 6 rolls is 5/36 to the 2nd times 31/36 to the 4th. There are 15 ways that 2 sums of 8 can occur in 6 rolls, so multiply that individual probability by 15. The probability of the sum of 8 occurring exactly 2 times in 6 rolls is 346,320,375 divided by 2,176,782,336. The numerator and denominator have a common factor of 3, so reduce to get 115,440,125 divided by 725,594,112, or approximately 1,591 ten-thousandths.